So how in the world are we going to feed a rapidly growing planet without completely exhausting its resources? It's, one of the biggest questions of our time. And the answer isn't just about planting more seeds. It's about farming smarter. So let's dive into this incredible tech revolution that's totally changing one of our oldest and most essential industries, agriculture.
And right here, this is the core of the challenge. By the year 2050, the global population is expected to hit a staggering 9.6 billion people. Think about that. To feed everyone, our farms are going to need to produce about a third more food than they do today. And they have to do it while facing the massive pressures of climate change and dwindling resources. It's a monumental task, for sure.
Now, what's so interesting is that we've kind of been here before. In the early 20th century, mechanization, tractors, and combines completely changed the game. Then, in the 60s, we had the Green Revolution with new crop varieties and methods. Each one was a huge leap forward. Well, today, we're in the middle of the fourth agricultural revolution. And this one is all about data, AI, and intelligence.
Okay, so let's zoom in from that big picture to one of the key heroes of this new era. It's a tool that's giving farmers a perspective they have literally never had before, the agricultural drone.
These things, unmanned aerial vehicles, or UAVs, are becoming absolutely essential. And what you're looking at here are the two main types you'll see out in the fields. On the left, you've got the multi-rotor drone, which is probably the kind you're most familiar with. And over on the right, that's a fixed-wing drone, and it looks more like a sleek little airplane.
So why pick one over the other? Well, it really all comes down to the job at hand. The fixed-wing drone can fly longer and way faster, which makes it perfect for mapping huge areas of land. But the rotary wing, the helicopter-style one, it can hover in one spot and it's incredibly nimble. That makes it ideal for getting up close for detailed inspections or even for spraying a treatment on a very specific patch of plants. And let's be really clear, these are not toys. They are seriously sophisticated flying robots. This diagram breaks down the whole system for you. You've got the drone itself, which is packed with all kinds of advanced sensors, and it's all communicating with a ground control station. They've become the farmer's new eyes and ears, collecting absolutely crucial data from the sky.
And this is basically their superpower. These drones are often carrying multispectral cameras that see light way beyond what our eyes can. So why does that matter? Well, because a plant that's under stress, whether it's from a disease, pests, or just not enough water, it actually reflects light differently. These cameras can spot those tiny invisible changes long before the damage becomes visible, giving farmers a massive head start.
So collecting all this information is just the first step. The real magic, the true power of this whole revolution happens next, when we turn all that raw data into smart, actionable decisions. It really boils down to this simple but incredibly powerful four-step process. First, you collect the data from drones and even sensors on the ground. Second, AI and machine learning algorithms chew through that massive amount of information. Third, that AI creates insights, usually in the form of prescription maps that pinpoint exactly which areas need help. And finally, you take action, applying water or fertilizer with almost surgical precision.
Now, the key thing to get here is that the drone isn't working alone. It's just one piece of this huge interconnected ecosystem. You have data flowing from everywhere. Sensors in the soil, UAVs in the air, even satellites way up in orbit, and it's all feeding into the cloud for analysis. Then, those AI-driven insights flow right back to the farmer, creating this complete real-time picture of the farm's health. And all of this leads to a concept called precision agriculture. It's the direct result of this whole data-driven approach. And it's a fundamental shift, moving away from farming that's based on, averages and guesswork, to a practice that's based on science, hyperlocal and in real time. You're not just treating the whole field the same anymore. You're treating each plant or each small patch exactly how it needs to be treated. Okay, so the tech is amazing, but what does it actually mean for the farmer's bottom line and for our food supply? Let's get into the tangible, game-changing results that come from all this. Let's just start with the big one, yield. Farms that are using AI-powered precision agriculture are seeing their crop yields jump by about 15 to 30%. That is a massive boost in productivity from the exact same amount of land and a huge step toward feeding those 9.6 billion people we talked about. And here's how they do it. By being incredibly, unbelievably efficient. We're talking about water use getting slashed by up to 60%, pesticide use cut by as much as 87%. This not only brings down overall costs by up to a quarter, but it has this huge positive impact on the environment. by reducing chemical runoff and conserving precious water. It's a win-win.
And listen, this isn't just theory. Just look at these real-world examples. A mid-sized wheat farm used drone monitoring and got a 15% yield increase while cutting water use by 40% and pesticides by 60%. A company called Terranus, which does leaf-level monitoring, has helped reduce crop losses by up to 50%. The numbers don't lie. This technology absolutely delivers.
So the benefits are clear, but believe it or not, this revolution is really just getting started. Let's zoom back out for a second and look at what's coming next and also what hurdles we still need to get over.
So it's important to know that precision agriculture is actually part of an even bigger idea: smart farming. Smart farming is the whole shebang. It's not just about crops, it's about weaving technology into the entire farm. Everything from tracking livestock health with GPS collars to making the supply chain more efficient and ensuring the whole operation is sustainable.
But look, this transition isn't going to be easy. There are definitely challenges. For one, the initial cost can be really high, anywhere from a couple thousand to over $20,000. Then there are big questions about who owns and controls all this valuable farm data. And critically, a lot of rural areas still don't have the reliable internet you need to make these systems work. Plus, farmers need new tech skills, and the AI itself needs more high-quality data to learn from.
So where is all of this headed? This quote really nails the next frontier. We're moving toward a future that combines this intelligent monitoring with autonomous robots. Just imagine a system that doesn't just use a drone to find a patch of weeds, but then automatically sends a little robot out to pluck them. It's a closed-loop system. See a problem? Fix a problem. All without a human having to lift a finger.
And that leaves us with this one last crucial question. This technology has the potential to help solve one of humanity's greatest challenges. There's no doubt about it. But as we move forward, the biggest hurdle might not be technical at all. It might be figuring out how we make sure these incredible tools are accessible and affordable for every single farm, from the giant corporate operations to the small family-run fields all across the world. How we answer that question, well, that will determine the true success of this revolution.